saying yesterday, let's take a look at examples. Example. We have 2x minus 5y plus 3 minus 7x plus 2y 6x. I want to simplify this. To be simplified. I want to simplify this. I want to simplify this. And while to simplify that, I'll have to pick up the like terms, irrespective of their signs. So to simplify, I have to pick up the like terms and group. Okay, then we will now evaluate the like terms until nothing else could be done. So let's go. The like terms here, if we start with x, we now have 2x minus 7x and 6x. So we have 2x minus 5y plus 3 plus 2y plus 6x equals 2x minus 7x plus 6x. These are x terms. So let's pick the y terms. Minus 5y plus 2y. Any other y term? Another one. Then we pick the constant plus 3. So 3 different terms here, x, y, and constant. So we put this together, 2x and plus 6x is 8x, minus 7x is 1x, which is x. That's how we write it. Minus 5y plus 2y. Remember, subtract them and give the answer the same of the bigger number. You have minus 3y, then plus 3. At this juncture, nothing else can be done because x and y are not like terms, which are also not like terms with the constant 3. Okay, some people may make the mistake of saying x minus 3y plus 3 will give you 6xy or minus 6xy, as the case may be. It is wrong. This is wrong. Why? Because our x is like a chair. You'll be saying one chair minus our y could be like a pen, 3 pens, and our constant could be anything. Okay, let's say plus 3 shoes. This is meaningless because you cannot remove pen from chair, and you can't add shoes to any of them so that they give you one thing. It's not possible. So that's what like terms are all about. It's just this. This should help you understand like terms better. You don't put things that are not, you don't put unlike things together to give you something, one unique something. No. Okay. So this is a simplification I'm talking about. Simplification of algebraic expressions. So we get examples, more examples coming our way. More examples coming our way in algebra. Let's take another example. We can have something like this. can have something like this to be simplified. To be simplified. Here, we have challenges. According to Bodmans, okay, we have the brackets to take care of first. But then, inside those brackets, we can't subtract x from 5 because they are not like terms. Inside here, we can't subtract 4 from y because they are not like terms. What do? We now open up the brackets via expansion. So we open the brackets via expansion. And to do that, we multiply everything inside the bracket by the number attached to the bracket, by the number multiplying that bracket, because 3 is attached to the bracket by multiplication, and the same thing with minus 2 by multiplication. So that's what we're going to do now. So we put it down. 5 minus x plus 3y minus 2 into y minus 4. This is equal to 2x minus 3. We multiply everything inside the bracket by this. Okay, minus 3 times minus x plus 3y, then minus 2 times y minus 2 times minus 4. Let me write it well. Is equal to 2x minus 3 times 5 minus 3 times minus x. This is multiplying this and also multiplying this. That's what I'm doing. Then plus 3y minus 2 times y minus the same minus 2 times minus 4. So this is equal to 2x. There is positive here, so minus plus times plus, we have minus 3 times 5, 15. Minus times minus plus 3 times x, 3x. We have our plus 3y. Then negative times positive here, negative. 2 times y, 2y. Negative times negative, positive. 2 times 4, 8. We can collect like terms now. We collect like terms, pick our like terms. So we have 2x plus 3y. They are like terms. Then plus 3y minus 2y here, we simplify it, is 1y, just y. Then these are also like terms, minus 15 plus 8. Another thing is remaining. 2x plus 3y is 5y. Oh, 2x plus 3x, sorry. 2x plus 3x is 5x. This is x. Then we have plus y. Minus 15 plus 8, we have negative 7. Nothing else can be done here. That's why we have our answer like that. Because this is in x, this is in y, and this is a constant. You can't put them all together to give you something unique. No, it's not possible. So this is our answer. So things like this could be done, algebra. So we have to now go to algebraic equations, simple algebraic equations. Now, equations are peculiar in their own terms. They are different from simple normal expressions. Equations are algebraic expressions. What I mean, simple algebraic equations are algebraic expressions which are separated by an equal sign. This is an equal sign, okay? Equal sign. This is an equal sign. So when you write, there are sentences, there are statements, there are mathematical statements. There are mathematical statements. You know, statements could be true or false. So we are interested in leaving our statements true. That's why we solve equations. For example, if I have something like box something added to 5 will give us 19. There is only one number which can make this true. There is only one number which can make this true, and that number is 12. So we use box here to represent what is missing, and we can easily find what is missing by how. That's how the howness, how to find what is missing, is the reason why we solve equations. So here we have 12 in our box, which will make this statement true. If we have any other thing there, if we have any other thing like 6, this statement is automatically false. It's false. So our goal is to find the missing term or number in an equation which will make that equation true. That is to solve an equation. So to solve an equation, is to discover or find the missing term or number or unknown which makes the statement true. So that's what we are going to do now. We will bring out ways we can solve equations thoroughly. We'll use the balance method, what you call the balance method. The balance method comprises of there are two sides of an equation. So whatever we do to the left hand side, we will also do that same thing to the right hand side. That's the balance. In order to keep the balance, given this as a balance, we must have seen something like this somehow in our lives. Maybe when we go to the market or the butcher's shop. So we have a balance like this. In our case, for the left hand side to be on the same level as the right hand side, the things here the weight here must be equal to the weight here. Here and they are empty right now. So if I have let's say here, if I have 4 grams of stone, 4 grams of stones, and here I have 8 lumps of meat. Okay, let me just use 4 grams of meat. 4 grams of meat. Making the balance to be on the same level. This is equal to this because you have 4 grams of different things. It doesn't matter what that thing is. What matters here is that they have the same weight. If I remove 2 grams from here, I will have something like this. If I remove 2 grams from this side, I will have something like this. So you see that same balance is skewed right now, and here they will no longer be equal. Okay, they will no longer be equal, so it's not balanced here. I still have 4 grams of meat, but I have 2 grams of stones here, so they're not equal. To make it equal, I will have to either put back the 2 grams. In a case where I have used the 2 grams, I can't put it back, so I will now have to remove 2 grams from here. If I remove 2 grams, it will come back to the same level. It will come back to this. So you see, now equal again. So the two sides will have equal weight again. You see. So you have 2 grams of stones and 2 grams of meat. So they are balanced. Here they are balanced. That is what this is about. That's what the balance method is about. So I will tell you now how to apply it in equations. So but before we do that, let's pick up the steps in solving equations. Steps in solving equations. So let's get steps. Here we'll be looking at the very simple equations, the very simple systems of equations, the ones without fractions, just linear equations, fractionless linear equations. That's what we're looking at here now. So those steps to solve an equation, is to let the unknown or variable stay alone. To let the unknown stay alone. To do this, we have to remove every number or term on the same side with the unknown, on the same side of the unknown, or on the same side with